We're going to work on factoring, and in this case, it's factoring perfect square trinomials. Now, this is essentially what a perfect square trinomial looks like in its base form. The first number can be square rooted. The last number can be square rooted. And the square roots of both of those times 2 will give us our middle value, which is essentially our b when we're talking about standard form. Now, this looks very different from what we've done before. But this number here, the standard form, is a perfect square trinomial. And if you notice, this is an a b, and a c value. There is no difference. The reason they show it to you this way is because they want you to look at another style of factoring for it. I'm going to show you that the normal style of factoring will work fine. You just at the very end have to recognize your answer. Okay? So we're going to go through our normal style of factoring, where we find the factors of the first term, 1 and 4, 2 and 2, and the factors of the last term, which are 1 and 9, 3 and 3. Okay? We're going to set up our columns here. We know the columns for the first factors are going to be our first terms in the brackets, and the second ones will be the second terms in the brackets. We know when we multiply across, the products need to multiply to our middle term, which is negative 12x. So I'm going to quickly go through this. 1 by 1 and 4 by 9 is going to give us 36 and 1. Will that work? No. Nope. 1 by 9 and 4 by 1 will give us 4 and 9. Will that work? No. No? Okay. 1 by 3 and 4 by 3 is 12 and 3. Will that work? No. And there's no difference when we go diagonally. So we know the very first column doesn't work. So we're going to try the second column here. 2 and 1 and 2 and 9? No. And when I go across, will it change anything? No. 2 by 3 gives us 6 and 6. Will those work? Oh, I did make a mistake in this question. Hold on. There we go. Okay. So, I left that out. I blame the pen. 2 by 3 and 2 by 3 are going to give us 6x and 6x. Remember, these factors technically have x's attached to them. Okay? And in order for it to add up to negative 12, they'll both have to be negative, which is fine, because if both of the 3's are negative, will they multiply to positive 9? Yeah, so we know that will work. So in our factored form, our first terms are going to be the 2x and the 2x. And our second terms are going to be negative 3 and negative 3. Now, do I have to worry about putting this negative 3 in the opposite bracket of that 2x? No. Why not? They're the exact same terms, so there's not going to be a difference here. Okay? Okay, so now, this is where the only extra step I want you to do from our normal style factoring, what have you noticed about the brackets? They're identical, which means we can represent them as 2x minus 3 squared, and that's it. Now, we're going to relate this answer to this style they've written up here. Let's see how this is related. What you would have noticed is in the first one they said a squared, okay? And the reason they've written it that way is because the way they would factor this, their answer would be one bracket, and it would be a. You would take the middle term there, so if it's a plus or a minus, in this case it's a plus, c, and square, okay? So, if you're able to notice this is a perfect square trinomial, all you'll have to do is find the square root of the first term. And what is our first term here? 4, so what's the square root of it? 2, okay? So 2 will be our a. Square root of the last term, 9, is what? 3. So 3 is our second term. And whatever the operation was in front of the b, in this case it was a negative, you put that operation in between. And you would get 2x minus 3 squared. Now that is another style of factoring that involves a lot more mental processing of the math. If you guys can just remember our way and recognize at the end, you just put it into one bracket. Okay, that's what a perfect square trinomial is.